Can you ever have a square root of a negative number? The answer is no. Okay, so we're looking at A right now. Okay, you cannot have a square root of a negative number. So A needs to be positive. Okay, or you can take a square root of a negative, zero, I mean. Okay, that's okay. So it needs to be greater than or equal to 0. Okay. And if you solve this, you get x is greater than or equal to -3. Okay. And that's A. All right. And you can confirm that because if you look at the graph here, look, that's the graph for A. Okay. This is -3. And x, the domain, has to be greater than or equal to -3. All right. Now, if you look at B, okay, if you look at B, remember your vase, your vertical asymptote, or let's just make it even easier, your denominator can never be 0. Okay? So what would make your denominator 0? Okay, is 5. Okay, so let's set it equal to x minus 5. Let's solve it. Let's see what x cannot equal to. I'm in fact going to put a slash through the equal sign, like that. All right, and I'm going to get x cannot equal to 5. Okay, which means x can be everything. So let me just actually, do you guys understand how they got that? Okay. Yes, and I forgot to say, okay, one more thing. So that's the denominator. I forgot to talk about the numerator. Okay, so this is for the denominator. Now let's talk about the numerator. Again, can you take a square root of a negative number? The answer is no. So x has to be greater than or equal to 0. Also, okay, for the numerator. Okay. So if we combine these two, x can be everything from 0 to 5. Okay, and that's 0 inclusive. And x can be everything from, let me just be quiet and see if you guys understand this green highlight. If I combine the denominator and numerator restrictions. Okay? And that's how I got the green highlights here. Okay? Again, because the numerator cannot be negative. So that's why I got this. Okay? That's how I got this right here. And your denominator cannot be 5. That's how I got this right here. Okay, when I combine these two statements here, for numerator and denominator, I get that, which mathematically mature way of writing that is this. Okay. All right, now for C, and if you look right here, by the way, here's the graph for B. Okay, here's the graph for B. And look, it does not go below 0, and there's a VA, a vertical asymptote, at 5. Okay. Now for C, okay, anytime you have a squared, if you square anything, if you square a positive number, if you square a negative number, it's always positive. Okay, it's always positive. So C is an easy one that you can use your reasoning for. Okay, X, or in this case S as in Sam, but I'm just going to use X. Well, let's just use, let's just stay with X. Is going to have to be greater than or equal to 0. Okay, and that's how they got this right here. Okay, and if you look at this parabola, which is the graph for C, it looks like that. Okay, so using the same logic, okay, you're just basically looking out for vertical asymptotes. When you do these problems here, you're looking out for vertical asymptotes. Okay, look out here for your vertical asymptotes. Remember, in this case, X cannot equal to a certain number because it makes the denominator 0. Same thing here. So you're looking for your vertical asymptotes. Okay, what can't X equal to? And then afterwards, you're going to be looking at your square roots to see what else X can't equal to, because you cannot square root a negative number. Okay, and from there, once you find out the VAs, which restrict X from becoming which restrict X, and you look at the square roots, which restrict X, okay, then you combine those two statements to create a domain, a final statement that looks like this. Okay, that looks like this, and finally translate that into the quote-unquote mathematically mature way of writing it. Okay. All right, and sometimes if there is no denominator, okay, if there is no denominator or numerator, if there is no denominator, like something like number 9, you might have something like all real numbers. Okay, I'm just giving you a heads up. Okay, so go ahead and do here. Let me show you which numbers to do. I'll actually keep